Hello viewers, in this video we'll go through Cambridge A-Level Mathematics, syllabus code 9701. This is component 1 and variant 1 from the May June 2025 series. We'll attempt question 3 in this video. The previous question is uploaded to the playlist. So this question is giving us a geometric progression in which the third term is 18. So I'll just write that down first. The third term of the geometric progression, which I'll use U3, is 18. And the sum of the first three terms, the sum of the first three terms of this geometric series is 26. It's given that the common ratio r is negative, so less than 0. So we have these three specification that the question has given us, and they want us to find what is the 10th term, u10, and three significant figures. So let's try and see what information we can work out here. So obviously first we need to find the ratio, right? We need for a geometric series, you can use in the formula sheet also here in the MF19. For geometric series, un we know is the a multiplied by r. A is the first term, r is the common ratio, so we need to find those two. And let me just write down that formula. Un equals to arn minus 1. So this is our governing formula for a geometric progression. So we know that the third term, right, u3 is 18 as given in the question. So we can use this information to try and form an equation. So u3, right, u and 3, it will be a we don't know, but r we still don't know, but n we know that will be 3. So 3 minus 1, that will be 2. Okay, and that we can equate to 18. So this is one of the equation we can get from the information. And for the second equation, we also know that the sum for a geometric series can be represented by this formula. So I will also write it down there, right? Sn a 1 minus r power n 1 minus r. So we know that the sum of the first three terms, S3, okay, a we don't know, so we just write it there. 1 minus r, so n will be replaced with a 3 there. The rest we just keep it as the same. So this is equal to 26, and this will be our second equation. So what we can do, we have two unknown variables and we have two equations. So it's definitely a solvable equation, right? So we can use, we can see a appears in both of the equations, so we can try and divide both of the equation together. The first equation divided by the second equation. So the a and a will cancel out, or let me just write it out. So on the left hand side, we have this thing, and on the right hand side is just the constant dividing each other. 18 divided by 26. A can cancel, this 1 minus r, I bring it up here. So I will have r squared 1 minus r over 1 minus r cubed. Then this I simplify to 9 over 13. And simplifying this, you should be able to get a cubic equation in terms of r. So after factorizing, you should be able to get three values for r, three possible answers for r. But as you can try and recall that the question is already specified that r must be less than 0, r must be negative. So these two, r equals to 1 and 3, they are positive. So we have to reject them. So our only answer is this one, r is negative 3 quarters. And logically speaking also, if you know that since it's a geometric series, if the common ratio is 1, so it's not really a progression, it will just be the same term over and over again. Okay, because anything multiplied by 1, it will just be 1. So now we have our r, we can go ahead and try and substitute back in the first equation. And you'll be able to find, right, r is negative 3 quarters, so you'll get 32. And this will be the two parameters that you have already specified. So now we want to find what is the 10th term to answer the question. So we just need to substitute all these values. So 32, that is our a multiplied by r, negative 3 over 4, and raised to the power of 10 minus 1. Okay, so you should be able to get negative 2.40. And so the question wants it in three significant figures. So yeah, try to remember to put it into three significant figures. Okay, part B of the question wants you to find the exact value of the sum to infinity of this progression. And again, we try and refer back to our formula sheet. The sum to infinity is given us with a formula with a condition where the modulus of the common ratio must be less than 1. So the common ratio must be between negative 1 and 1, which as we have found in our previous question, r is negative 3/4, which fit that criteria. So we can use this formula. So the sum to infinity, I'll rewrite the formula here. And since we already have all our values, a we have as 32 and r we have as negative 3/4. So we can just substitute and just apply the formula. And you can try and simplify this because they want the exact value. So we are not able to just directly type into the calculator. We will try to simplify something like that. And then we can give it as a fraction. So 128 over 7. And this will be the final answer of this question. So there we have answered the two parts of question 3 of this paper, and hope you have learned something, and thanks for watching.